Hi all, welcome everyone to my channel ChemFlix. And in this video, I'm going to share you about the oxidation state of an element. How can you determine the oxidation state of a particular element in a compound, and how it is related to this periodic table. How can you find easily this oxidation state from the periodic table, and so on. Okay, so let's see. Before that, if you're new to this channel, please subscribe it, and if you like this video, please click on the like button, okay, and share among your friends. So today, this is the oxidation state of an element, and at first we're going to discuss about what do you mean by this oxidation state or the oxidation number. Okay, so oxidation state or oxidation number, it represents the total number of electrons. It represents the total number of electrons lost or gained by it. A total number of electrons lost or gained by it. For example, we all know that the atomic number of sodium, okay, we all know that the atomic number of sodium is 11, okay, so we all know that the atomic number of sodium is 11, okay, give me a minute. So here the electronic configuration, main shell electronic configuration can be written as 2, 8, 1. So what happens, the sodium, it loses one electron, okay, one of the electron, it loses this electron to get the sodium positive ion, okay, Na positive ion. So here 2, 8 to become 2, 8, that is the electronic configuration. And here what happens, the sodium, it loses one electron to get this positive charge. Therefore the oxidation state of sodium is +1, okay. So the oxidation number is, or the oxidation state of an atom is a number that represents the total number of electrons lost or gained by, total number of electrons lost or gained by. This is actually the oxidation state or oxidation number. So in order to find out the oxidation state or oxidation number, there are certain rules. So now we're going to see these rules, okay. So rules for the oxidation number. So rules to find out this oxidation number. So the oxidation number of a free element is always 0. For example, I'm taking a free element. For example, I'm taking manganese. Okay, I'm taking manganese. Or either you can take a iron or whatever. This is calcium or whatever you're taking this element. If that element is in free state or free element, if this is a free element, then the oxidation number is always 0. Okay, the oxidation number is always 0. So what is the oxidation number of manganese? The oxidation number of manganese is 0. So this is not in a combined state, or it's not in a compound. This manganese is not in a compound, or manganese is not in a combined form. It is free in nature. Okay, it is free. So here this is a free element, and the oxidation number of this free element is always 0. So the oxidation number is 0. Here this is also 0. This is also 0. That is the rule number 1. And now moving to the rule number 2, that is oxidation number of a monoatomic ion. Monoatomic ion equals the charge of the ion. For example, we already discussed about the sodium positive. Okay, so this is a monoatomic ion. So this is an ionic state. This is a cation. Suppose another one example, this is Cl minus. You already know about the Cl minus because it accepts one electron in order to attain the octet configuration in its outermost shell. Chlorine, the atomic number is 17 and the electronic configuration is 2, 8, 7. And in order to attain the octet configuration, it needs one more electron. Therefore, Cl becomes Cl minus. Okay, chlorine is an anion. Chlorine minus is an anion. So here, the second rule states that the oxidation number of a monoatomic ion equals the charge of the ion. So here the charge of sodium cation is +1 and the charge of chlorine anion is -1. That means the charge of the ion itself is the oxidation number. Okay, that is the second rule. Moving to the third rule, that is the oxidation number of hydrogen is +1. Okay, what is the oxidation number of hydrogen? It is +1. But it is -1 in when combined with the less electronegative elements. So when it combined with the less electronegative elements, which means more electropositive elements. If it combines with the more electropositive elements, for example, if this hydrogen combines with this sodium, okay, if this hydrogen combines with the sodium to form metal hydrides, okay, metal hydrides, these metals are very electropositive in nature, so it will lose electron and it will form this cation, and in this particular case hydrogen will act as a anion. That means this type of anion can be called as hydrides. Okay, this type of anions can be called as hydrides. Okay, hydrides. So here in hydrates the oxidation state will be -1. So in hydrates the oxidation state will be -1. That is the rule number 3. So the first rule is in the free element the oxidation number is 0, and in the monoatomic ion the oxidation number is same as the charge of the ion. And the third rule is hydrogen the oxidation state is of course it is +1, but when hydrogen combines with a more electropositive element like sodium, alkali metals, okay, more electropositive elements, they form hydrates. So for example metal hydrates, in the case of metal hydrates they form, the oxidation number of hydrogen is -1 and they form hydrates. That is the third rule. And I'm coming to the fourth rule. This is our fourth rule. Okay, so fourth rule, okay, in the fourth rule the oxidation number of oxygen in compounds is usually -2. So the oxidation number of oxygen. Okay, now we are going to discuss about the oxygen, the oxidation number of oxygen. So oxygen the oxidation number is -2. Okay, -2. But in peroxides, I will show in the coming slide, in the peroxides the oxygen will show -1 oxidation. That is one rule, you have to study it. Okay, in the case of peroxides like hydrogen peroxide, okay, now we're going to discuss about that. So the fourth rule is the oxidation number of oxygen is usually -2, but it is -1 in peroxides. Okay, and now to the fifth rule, that is the oxidation number of a group 1 element. Group 1 element, that means the alkali metals. Group 1 elements means the alkali metals. Okay, in the case of alkali metals, the compound, the oxidation number is +1. You all know that. Okay, I will show you that with a periodic table. And the oxidation number of group 2 elements is +2. Okay, and the oxidation number of group 17 elements in a binary compound is -1. Okay, please note down the term, in a binary compound is -1. Okay, and this is the 6th rule, 7th rule. Okay, now to the rule number 8. Here the sum of the oxidation number of all the atoms in a neutral compound is 0. You have to maintain the neutrality. Okay, so the sum of the oxidation number of all the atoms in a neutral compound, for example we are going to discuss about NaCl. Okay, NaCl. So the sum of the oxidation number, here now you know that the chlorine, it accepts 1 electron to form Cl minus, and sodium it loses 1 electron to form +1, and the sum of the oxidation number, so here +1 plus -1, okay, +1 plus -1, which is equal to 0. That means the sum of oxidation number of all the atoms in a neutral compound, so here it is a neutral compound, is 0. Okay, and the last point is the sum of the oxidation numbers in a polyatomic ion is equal to the charge of the ion. Okay, so in the polyatomic ion, for example, for the case of sulfur, a sulfate anion, it is 2 minus, SO4 2 minus, that the oxidation number is the charge itself. The oxidation number of the sulfate anion is, it is the charge itself, that is 2 minus. 2 minus will be the oxidation number. Now here you can see some exceptions that we already discussed, some of the exceptions, that is hydrogen in metal hydride. We already discussed in the case of metal hydrides. Hydrogen, the oxidation state of hydrogen is -1. Okay, the oxidation state of hydrogen is -1 because of the electropositive, more electropositive metal ions. Okay, the metal hydrides include compounds like the sodium hydride, NaH. Here the hydrogen exists as a hydride ion, H minus. The oxidation state of a simple ion like hydride is equal to the charge of the ion, in this case is -1. Okay, same. And in the another one exception is the oxygen in peroxide that we are going to discuss now. Peroxide includes hydrogen peroxides. This is an electrically neutral compound. So this hydrogen peroxide, so H2O2, is an electrically neutral compound, and we all know that the oxidation state of oxygen is -2. We already studied in the rule 2, and here the oxidation state of this oxygen in hydrogen peroxide, it is -1. Why is it so? Because in order to balance, you know that the oxidation state of hydrogen, it is +1, and here +1 into 2 plus x will be equal to 0, and this x will be -2. Of course it is -2. So if it needs to be -2, then the oxidation state of oxygen should be -1. Okay. So that is, peroxides include hydrogen peroxide. This is an electrically neutral compound. So the sum of the oxidation state of the hydrogen and oxygen must be 0. Okay, the sum of the oxidation state must be 0. And because each hydrogen has an oxidation state of +1, each oxygen must have an oxidation state of -1 to balance it. That's the thing. And the third assumption is that oxygen in F2O, okay, F2, you know, fluorine is more electronegative than oxygen. So the deviation here stems from the fact that oxygen is less electronegative than fluorine. Okay, the fluorine takes priority with an oxidation state of -1. You know, fluorine being the 17th group, it needs one more electron to complete the octet. Okay, 17th group, which means the atomic number of fluorine is 9, that is 2,7. It will be the main shell electronic configuration. So it needs one more electron to attain the octet configuration. So fluorine, the charge will be -1. Okay. So the electronegativity that fluorine takes priority with an oxidation state of -1. Because the compound is neutral, the oxygen has an oxidation state of +2. Here the oxidation state of oxygen is +2. Okay, so oxygen shows 3 types of oxidation, that is -2 mainly, -1 in the case of peroxides, and +2 in the case of more electronegative element when combined with oxygen, like fluorine. Okay, so these are the oxidation state of oxygen. Now I am going to tell you the fact that is about this alkali metals and alkaline earth metals. So in alkali metals, you know, for the lithium, sodium, potassium, here you know the outermost shell contains only 1 electron. Okay, outermost shell, if this is the last shell, okay, outermost shell contains 1 electron. That means the valence electron is 1 in the case of first group, and in the case of second group, you can see the valence electrons, there are 2 valence electrons. So of course the oxidation state of the first group will be +1. That means they need to lose 1 electron to get the octet configuration, and the oxidation state of the second group will be of +2, that they need to lose 2 electron to gain the octet configuration of +1 and +2 will be the common oxidation state shown by the first group and second group elements. And now coming to the 70th group, you know, we are taking this fluorine as the example. Fluorine, the atomic number is 9, so the electronic configuration will be 2,7, and it needs one more electron to attain the nearest noble gas configuration or the octet. So fluorine, the oxidation state will be -1. Okay, fluorine, the oxidation state will be -1. That means the 17th group, the oxidation state will be -1. Okay, common oxidation state will be -1. Okay, so there you can see some of the examples. Okay, here you can see some of the examples, that is CO2, CO, C, CH4, C, that we in the rule 1 that we already discussed, it's in the elemental form, so the oxidation state will be 0, and H2 also, this is 0, chlorine also it is 0, and oxygen, ozone, they are all 0, which means they are, we already discussed there that they are, oxidation number of a free element is always 0. Okay, now coming to this CO2. Okay, CO2, you know that oxygen, the oxidation state of oxygen is -2, and here 2 oxygen atoms are there, so -2 into 2 will be the total charge. So -2 into 2 will be the -4 is there. So in order to balance this, +4 will be the charge of carbon. Okay, so that is the rule number. Says that is rule number 8 says that the sum of the oxidation number of all the atoms in a neutral compound is 0. So neutral compounds, here is an example. This is the example for a neutral compound. So CO2. Okay. Example, that is carbon dioxide. Okay, sorry. Carbon dioxide. Carbon dioxide. Okay, in carbon dioxide there are two elements, so there carbon and oxygen. Okay, carbon and oxygen. So you know that from this rule already we studied that the oxidation number of oxygen in compounds is usually -2. Okay, so now we are taking this that the oxidation state of oxygen here it is -2. So -2. Okay. And one more rule that you have to think about it is that rule number 8. Okay, that means the sum of the oxidation numbers of all the atoms in a neutral compound is 0. The sum of the oxidation numbers of all the atoms. Okay, the sum of the oxidation number of all the atoms in a neutral compound is 0. Considering these two rules into our to find the oxidation state of carbon dioxide, to find the oxidation state of carbon. Okay, now we're going to find out the oxidation state of carbon. So here you know that the oxidation state of carbon can be taken as X. Okay, and you know the oxidation state of oxygen is -2, and here there is 2 oxygen atoms are here. Therefore 2 into -2, which is equal to 0. That is according to rule number 8. So you will get this X is equal to +4. That is the oxidation number of carbon in this carbon dioxide is oxidation number of carbon is +4. Okay, is it clear? So taking another one example, that is example B, that is sulfur dioxide. The same thing, that you need to find out the oxidation state of sulfur. So you all know that, you already know that the oxidation state of oxygen is -2, and there are 2 oxygen atoms are here, and we should take the oxidation state of the particular element that we need to find out as X. So the total sum of these elements will be equal to 0. So therefore X is equal to 2 into -2 is -4. So -4 when it comes to the right hand side, it will be +4. Okay, same thing. In sulfur dioxide and carbon dioxide, you will get the oxidation state of sulfur as +4 and the oxidation number of carbon as +4. Okay, so now I am going to see another one example, that is how will you find out the oxidation state of sodium here. Okay, how will you find out the oxidation state of sodium? So here you know that sulfur SO4 is a polyatomic anion. And the charge of this polyatomic anion is -2. Okay, charge of this polyatomic anion is -2, and here there is one such polyatomic anion. Okay, one polyatomic anion is here, the number quantity is 1. And moving to this hydrogen, the oxidation state is +1, as already indicated in our rules while we are discussing the rules. And moving to the sodium, we need to find out the oxidation state of sodium. You need to find out. So take the oxidation state of sodium as X. So X plus the -1, that is 1 into -1 will be 1 into +1 will be the oxidation state and the number of hydrogen here, plus sulfate anion. There is only one sulfate anion is here. 1 into sulfate anion, it is the charge is -2, that is the total charge, so it is equal to 0. According to rule number 8, the total sum of the oxidation number will be equal to 0. So now you can find out the value of X as 1 into 1 is 1 itself, plus 1 into -2 is -2. So -2 when it comes to the right hand side, it is +2, and +1 then comes to the right hand side, it is -1. So therefore X is equal to 1. That means the oxidation state or the oxidation number or oxidation state of sodium is equal to +1. Clear? Another one example, we're going to consider another one example. Okay. Okay, you can take the examples from our previous slide. We already seen there. Okay. K-manophore. Now we're going to discuss about the K-manophore. Now that means we are finding the oxidation state of manganese. Okay, KMnO4. Okay. So here the thing that you know is for alkali metals, as per the rule, for alkali metals, the oxidation state is, or oxidation number is equal to 1. Okay. And another one rule is that the oxidation number of oxygen is equal to -2. Okay, so you know that two things that you know, and the another one rule, that is the total sum of the oxidation number. Total sum of the oxidation numbers will be equal to 0. Okay, so now we are taking this, going to find out the oxidation state of manganese. Okay, oxidation state of manganese. So here K, the oxidation number of K atom, that is number of potassium atom, is 1. So 1 into the oxidation state of K is 1 plus Mn that you have to find out. So it is X, taken as X, and then oxygen, the number of oxygen atom here is 4, and the charge on oxygen is -2. So it is equal to 0. Then you need to find out. So 1 plus x plus -8 is equal to 0. Therefore, x is equal to plus 8 minus 1, which is equal to plus 7. So the oxidation state of manganese here is, oxidation state of manganese is, it is Mn, is equal to plus 7. Clear? Taking in another one example. Okay, another one example we are going to discuss here is calcium fluoride, CaF2. Okay, so here you have to think about this rule, that is the fluorine, which is in the 17th group. Okay, 17th group, that is our halogen family. Okay, for halogen family, the oxidation state will be -1. Okay, the oxidation state will be -1. Why is it so? Because it needs one more electron to attain the octet configuration in its outermost shell. So you're going to find out the oxidation state. If you don't know the oxidation state of calcium, you're going to find out. So here X plus 2 into -1, which is equal to 0. Therefore X is equal to 2. Therefore the oxidation state of calcium is, oxidation state of calcium here in this calcium fluoride is +2. Okay. Okay, so the last example is example 5. That is, I'm taking K2Cr2O7. It is nothing but our potassium dichromate. So here also you're going to find out the oxidation state of chromium. Okay, so how will you find out the oxidation state of chromium? So here you know that the oxidation state of alkali metals are, thus is equal to +1. Okay, here this potassium which is under the group 1. Okay, group 1, that means the alkali metal. So group 1, so potassium, it is in the group 1, or it is an member of alkali metal family. Okay, so here the oxidation number is +1. And the next thing that you know, that the oxidation state of oxygen, it is -2. Okay, oxidation state of oxygen is -2. And the rule number 8 that you have to take in care is the total sum. Okay, total sum will be equal to 0. Okay, sum will be total, not sum, is equal to 0. So now we are taking, now we are going to find out the oxidation state of chromium. So here you know that, so from here 2 atoms of potassium is there, the 2 into multiplied with the charge, that is +1. and then 2 into plus 2 into chromium. So here 2 chromium are there, 2 into X. Oxidation state of chromium is X. You have to consider the oxidation state of chromium as X, plus 7 into 7 atoms are there, 7 atoms of oxygen are there, 7 into our oxidation state of oxygen is -2, so therefore 7 into -2, which is equal to sum 0. That is, the sum is equal to 0. So here, while you are taking this, while you are solving this, here you will get it as 2 plus 2x plus 14 minus 14 will be equal to 0. Okay, so here 2x minus 14, 2 minus 14 is 12. Okay, so 2x minus 12 is equal to 0. That is 2x is equal to 12. Therefore, x, the oxidation state of a single chromium, is equal to 12 divided by 2 is equal to 6. So, chromium here in potassium dichromate is in +6 oxidation state. The oxidation state of chromium in potassium dichromate is +6. I think it is clear for you all. And if this video find helpful, please give it a thumbs up. If you want to see future videos like this, click on the subscribe button. That way you will get a notification. Alright, well, that's all I had for you today. I hope you like this and hope to see you next time. Bye.